Welcome to qnawire.
Here's our steel tank. Now, first thing I want to do is look at these forces, right? So if it were to float, we would have a buoyancy force up. We would have a force of gravity down of the helium. And we would also have force gravity down of the steel. Let's sum our forces. FB is equal to Fg helium plus Fg steel. Buoyancy force is equal to the weight of the air displaced, so this is going to be m air displaced. G, I'm just going to write ma. G is equal to m helium, G, plus the mass of the steel, G. Okay, so looking at this equation, we know that it will float if ma is greater than mhe plus ms. Well, now the tricky part is finding all of these values. So let's start with ma, displaced air, weight of displaced air. Start with the ideal gas law, PV equals nRT. We know our volume of the sphere is 4/3 pi r cubed. We can express n as the mass of air over the molecular mass of air, molar mass, RT. So we can express ma as p 4/3 pi r cubed m air over RT. Similarly, with the mass of helium, we can start with the same thing, PV equals nRT, work our way down, P 4/3 pi r cubed is equal to mhe over molar mass he RT, and then express our mass of helium as P 4/3 pi r cubed molar mass of helium over RT. Now we need to look at the mass of the steel. So we know that when looking at tensile stress and stress, we can express that relationship within a sphere of thickness T as P pi r squared is equal to stress 2 pi r T. We can express therefore T as PR over 2 sigma, and we know that our mass of steel is also equal to the density of steel times the volume, which is of course equal to the density times the volume of the shell, which is 4 pi r squared T, which we can then plug in for T to get rho s 4 pi r squared times PR over 2 sigma for ms. So let's return to our equation where we had m air G is equal to m helium G plus msg. We can take out the g's and put these numbers in, or these values in. Equal equation, sorry. P 4/3 pi r cubed m air over 3 RT, over RT is equal to P 4/3 pi r cubed m helium over RT plus rho s 4 pi r cubed P over 2 sigma. We can cancel out a bunch of stuff and we're left with molar mass of air over 3 RT is equal to the molar mass of helium over 3 RT plus the density of steel over 2 sigma. Now we can put some values in here. So the molar mass of air is about 28.9. Molar mass of helium is about 4.00. We know R, right? We can assume T is about 20 degrees Celsius or 293 Kelvin. The density of steel can range, but we can use the value 7,860 kilograms per meters cubed. You plug all of these in and you should be left with the expression on the left side. 3.96 times 10 to the negative 6 is equal to 8.41 times 10 to the negative 6. Now remember, this direction, the left side, was positive for us, so this would be up, and the one on the right is down. And because down is greater than up, we know that it in fact will not lift. Now, if you were to, let me just write this, not lift. If you were to see what the sigma would be that would allow it to lift, well, you just can set this equation that we had just solved equal to sigma. And if you do that, you can find that our sigma nu, I'm going to say sigma 1, would need to be about 2.31 sigma naught original.